Okay, let's take a few minutes and go through some of the parts of this packet for the first 4 pages here. So the first part was more background information. You didn't really need to complete anything here. Gives you information on squares and circles for males and females. Some of this background between marriages or unions, and then offspring in different generations. Um, so hopefully, as you're going through this, you read this carefully and didn't just skip to the blanks, because you'll have trouble with the blanks if you didn't read any of this. So let's go ahead and move down here a little bit. Again, some background information here. Talks about dominant and recessive. You should be familiar with that. Here, I'm not going to go through all of these because they're pretty straightforward. You just had to look back up to the first page there to get some information on which is male, female, marriage, things like that. Let's look at number 7 here. How many generations are shown in this chart? So the easy way to check that is basically you're just counting. It's kind of like levels. So if you think about one line here, level here, two lines here, levels here, and then 3 here. So you should have had that there are 3 generations. Okay. Let's see. So if we assume that the chart above is for a white forelock, okay, that's a white tuft of hair on the forehead. Usually, well, I wouldn't say usually, many times found kind of right along the hairline at the top of the forehead there. Sometimes it's found a little bit farther back. I have a friend a girl actually, who has one kind of in the top of her head that comes out. So what is the most likely genotype of individual A? So we're looking at individual A here. Okay? And you should have had, for genotype, you should have had capital F, lowercase f. In other words, heterozygous. This person would be heterozygous. Let's think about why that is. So if we look at these two individuals, right, you have mom and dad here. If we look at those two individuals, we know that some of their offspring, so they have how many children? They have 1, 2, 3, 4 children. Remembering that these individuals, okay, so this daughter over here married a male, a guy here, and this son here married a female, this son married a female. So these 3 individuals are not blood relatives of the parents. They're not offspring. They are daughters and sons-in-law, as we call them. So if we look at this, if we have mom, okay, who has the white forelock, dad does not. If mom, so mom having the white forelock could be either homozygous dominant or heterozygous. However, if mom were homozygous dominant, then it would be, you should draw out the Punnett square on this. I'm not going to do it for you right now, but you should realize that capital F, and lowercase f will never result in any lowercase f kids. So that in this case, if you have some kids, you have half the kids who are affected and half the kids who are unaffected. In this case, we know that mom has to be heterozygous. Second one here, or number 9, pardon me, what is the most likely genotype of individual C? Okay. You should have had homozygous recessive for this one here, lowercase f, right? Okay, because he is unaffected, and the only way to be unaffected is to have both those lowercase alleles. Okay, let's scroll down a little bit. Let's look at our first example, tracing the path of an autosomal recessive trait. In this case, the trait is called Fanconi anemia. The dominant form is normal bone marrow function. Pardon me, I can't speak apparently. In other words, no anemia. The recessive form is the resulting ailment of Fanconi anemia. And it gives you some background information if you're curious there. So as we look at these, so here's a typical pedigree for a family that carries. carriers are not indicated. There's no half-colored carriers in this particular case. But George and Arlene are the parents. We see that George is unaffected. He does not have Fanconi anemia, and Arlene does. So the first question that's asked here is, what is Arlene's genotype? Well, we know that since we look up here, the recessive form is Fanconi anemia. In order for the recessive to be expressed, we must have both recessive alleles, right? So in this case, you would have for Arlene, and it tells you to use F's here, lowercase f, also known as, homozygous recessive. Yeah? George's genotype must be heterozygous. Here, as we look back up, he must be heterozygous, kind of like in the last example with the forelock, because if George were homozygous dominant and Arlene is homozygous recessive, they would have zero chance of having any affected offspring, and in fact, they have 2 affected offspring. It has to be capital F, lowercase f. Again, do the Punnett square on it, right? If you do that, you'll see that 25% of the time you can end up with or 50% of the time, pardon me, you can end up with the Fanconi anemia. All right, the next one, what are Anne and Michael's genotypes? So Anne is the daughter of George and Arlene here. Michael is her husband. Anne and Michael must both be heterozygous because they have an offspring, a daughter, Carla, who is affected by the disorder. If either one of them, and this is the exact same example that I gave you with my sister and I having blue eyes and both my parents having brown eyes, is that if either one of these, let's say one were homozygous dominant, capital F, and the other were homozygous or heterozygous, then you would end up with 0% chance that any of their offspring could have the disorder. The next question says most likely, and that's an important caveat here, most likely Sandra's genotype is, this would be homozygous dominant, capital F, because if you look at Sandra up here, Sandra and Tom, Tom is affected, but none of their children are, well, they have 2 children, neither of their children or even grandchildren are affected by this. So in all likelihood, Sandra would be homozygous dominant. The last question here is number 5. List 3 people from the chart other than George who are most likely carriers of Fanconi anemia, because that is not particular or specifically labeled in this pedigree here. So there's actually 5 options. So you just had to name 3 of these. You could have had Daniel, Sam, Anne, Michael, or Alan. And so any of them would be carriers, and carriers would have a genotype of capital F, lowercase f. Otherwise known as, yes, heterozygous. All right, our next example is looking at a trait called neurofibromatosis. Gives you some background information there on what that means. The dominant form is neurofibromatosis caused by the production, yada, yada, yada. You can read that. Okay, but this is different. This one's the dominant form is the disease or disorder itself. The recessive form is normal protein. In other words, no disorder, no neurofibromatosis. So if you look at this one, we're looking at this pedigree here, and I would really encourage you guys to just, if you want to put them in your notebook, that would be preferred, but drawing these out does not, it's lines, circles, and squares. It really doesn't take you much time, and I find that doing it by hand, you'll learn it a lot quicker than just staring at pictures and trying to picture things, and rather than writing each of the genotypes next to. And what I always like to do is, as I draw these and go through and think about it, write as many of the genotypes as you can figure out next to each of the individuals, the males and females in these pictures. So we're looking at the first question here, is individual 1, okay, so we have individual 1 here, most likely homozygous dominant or heterozygous? And so look at what you put for your answer. The correct answer is heterozygous. And the reason is because the only way to get offspring who are both affected and unaffected by neurofibromatosis is to have individual number one's genotype be heterozygous. In other words, capital N, lowercase n. Since the spouse of individual one here is unaffected, okay, they must be genotype lowercase n, or homozygous recessive. If individual one were homozygous, all of the offspring would be affected by neurofibromatosis, and we see that they are not. They had five children, and they had 3 who were affected and 2 who were not. All right. Number 2 says, what is the genotype of individual number 3? So we're looking at this male here, and that individual would be homozygous recessive, lowercase n. Number 3, can you be sure of the genotypes of the affected siblings of individual 3? Okay, so these are the siblings, right? So individual 3, this is his brother, his sister. These are his parents. Okay? And the answer you should have had there is no, you cannot be sure or certain of that. It is certain that the 2 unaffected siblings, okay, are genotype lowercase n, or homozygous recessive. The 2 affected siblings would be either genotypes capital N, lowercase n, heterozygous, or capital N, homozygous dominant. One of the parents of individual 3 is known to be heterozygous, okay? Capital N, lowercase n. The spouse, known as individual 2, must also be heterozygous in order to have any unaffected offspring. And that's it for the first 4 pages here. You're going to have 3 more pages with some more complicated pedigrees in a couple activities here. But this gives you a little rundown of what your answers should have been. You can check your answers. Hopefully you got almost all these right. If you got any wrong, hopefully realized what happened and why you got them wrong. If you're having trouble with this, you feel like you're really lost, of course, this is a perfect opportunity. Please email me. I can try to answer your questions, or sometimes with this kind of thing, it's sometimes easier just to set up a phone call and we can chat for 5 minutes rather than emailing back and forth for 2.5 days. So keep that in mind, and good luck with the next few pedigrees that you'll have in your next activities.